Welcome to the second section of the video course, Advanced Tools and Techniques Beyond Base R. This section is on using the ggplot2 package to draw statistical graphics. We'll begin this section with a brief introduction to the grammar of graphics, a theoretical model for understanding the relationship between data and statistical graphics, which helps us to create informative and comprehensible plots. Then, we'll learn how to use the ggplot2 package to draw basic statistical plots in R. We'll learn how to save these plots to file. To finish this section, we'll learn how to find and install packages that extend ggplot2, and learn about two packages that allow us to create animated ggplot2 plots. This video is on understanding the grammar of graphics and ggplot2. In this video, we'll learn about the two most important concepts in the grammar of graphics: how aesthetics and scales relate data variables to plot features, and how geoms and stats express the data. We'll learn how different coordinate systems can be used to draw the same plot elements in different ways. Finally, we'll learn about how faceting can be used to draw subsets of the plot as separate plots. Let's begin with a brief introduction to the concept of the grammar of graphics. The grammar of graphics is a systematic description of how statistical graphics, such as pie charts or scatter plots or box plots, express the underlying data. The concept originates with a book published by the statistician Leland Wilkinson in 1999 and was implemented in the ggplot2 R package by Hadley Wickham in 2005. ggplot2 is among the most popular and widely used R packages in existence, and is now a core part of the tidyverse of packages you learned about in the previous section. The grammar of graphics describes how datasets are expressed in statistical graphics. Let's consider the iris dataset, which comes built into R, as a standard example dataset. It contains the measurements of various features of a set of iris flowers from different species. This plot, commonly called a scatter plot, is an expression of three of the variables in this dataset: petal length, sepal length, and species. Let's consider for a moment how these three variables are expressed in the plot. The variable of sepal length is expressed by the horizontal position of the colored dots, or in other words, their position on the x-axis. In ggplot2 terminology, this relationship between a variable and a property of the plot is called an aesthetic mapping. We can say that the variable sepal length is mapped to the aesthetic property of position along the x-axis. Similarly, we can say that petal length is mapped to the aesthetic property of position along the y-axis. What about species? If we look at the legend to the right side of the plot, we can see that species is mapped to the color of the points, each of which represents a single flower. Note that there is a subtle difference between the x and y-axis aesthetics and the color aesthetic. A point could be drawn anywhere along the y or x-axis and represent a value with any degree of precision that our computer screen is capable of drawing. A point could be drawn halfway between the 5 and 6 on the x-axis, representing a sepal length of 5.5, for example. However, the species variable can only be mapped to one of three distinct colors. We couldn't have a flower that was half setosa and half versicolor. In ggplot2 terminology, the x and y axis aesthetics in this plot have a continuous scale, that is, they encode variables with numeric values of arbitrary precision, while the color aesthetic has a discrete scale. It can only represent a fixed set of distinct values. However, there's no reason we have to draw the plot in this way. Suppose we switch the aesthetic mappings for the species and sepal length variables. Now the x-axis aesthetic expresses a discrete scale, with each vertical column mapped to one of three species. The color aesthetic now expresses a continuous scale, with the tone of blue mapped to sepal length at an arbitrary precision. In ggplot2, scales are the mappings between the value of a variable and a graphical property, such as position on an axis or color. The difference between aesthetics and scales might seem a little confusing at first, but they are actually quite distinct concepts. Aesthetic mappings describe which variables are mapped to which graphical elements: species to the x-axis, petal length to the y-axis, sepal length to color. Scales describe how that mapping is expressed. This means we can change a scale without changing the aesthetic mappings. For example, this means we can change a scale without changing the aesthetic mappings. For example, we could change the y-axis from a linear scale to a logarithmic scale, or the color scale could be changed from tones of blue to tones of red. Note that the aesthetic mappings have not changed. The y-axis aesthetic still represents petal length, and the color aesthetic still represents sepal length. All that has changed is how these properties of the plot express different values of the variables. Now let's turn our attention to the points themselves. We already know that each point represents a single observation. that is, a set of measurements for a flower. In this plot, each observation is drawn as a point. However, other than convention and good design, there's no particular constraint that forces the observations to be drawn as points. For example, we could draw them as squares, or even as text, giving the name of the species. Note that in this case, we've also added an extra aesthetic mapping, the contents of the text to the name of the species. In ggplot2 terminology, the graphical element that is drawn on a plot to represent a piece of data is called the geom, G-E-O-M. We've just seen examples of points, squares, and text used as geoms, but ggplot2 supports a much larger range of useful geoms, some of which we'll learn about in the coming videos. ggplot2 also provides a set of graphical elements closely related to geoms called stats. Stats represent statistical summaries or transformations of the data. For example, this box plot shows the median, first and third quartiles, range, and outliers for values of petal length within each species. These statistical properties are expressed through a box plot geom that draws lines, boxes, and points. Aesthetics, scales, geoms, and stats control how individual data points are drawn in a plot. In addition, there are two more important concepts in the grammar of graphics that control the overall appearance of the plot. The first is the coordinate system. Let's return to our original plot, which maps sepal length to the x-axis, petal length to the y-axis, and species to color, with point geoms representing each observation. The x and y axes are drawn on a standard Euclidean plane, as horizontal and vertical lines perpendicular to each other. However, we could also draw the same plot in an alternative coordinate system. The most common alternative system used in statistics is the PolarCoordinate System. In this system, the y value is drawn as a distance from a central point, while the x value is drawn as the circular angle around the point. Note that the fundamental plot properties of aesthetics, scales, geoms, and stats have not changed. In the space of the plot, the x and y axes still exist, and the same observations are still drawn at the same x and y values. All that has changed is how those x and y axes are drawn on the screen. Finally, the grammar of graphics describes a way in which subsets of the data can be split between separate panels within a plot. This is called faceting. In this example, the plot is being faceted by species, with each iris species drawn in its own plot panel. Note that, as with changing the coordinate system, the fundamental properties of the plot have not been altered. Each panel has the same aesthetic mappings, the same scales, and the same geoms.